Hello everybody, welcome back to the stream. So today we'll be learning lists in C++. So as you can see, we'll be learning lists. So let's see what lists are first. So, list is also another type of data structure, which is similar to a vector. It can also store multiple elements, dynamically grows in size. The differences are that you can add and remove elements from both the beginning and the end. Vectors can only do it at the end. Um, a list does not support random access, right? In vectors, you cannot directly jump to a specific index or access elements by index numbers. So that is about a list. So you need this header file. So after that, this is how we can create a list. So let me just go to VS Code. Let's start coding list.cpp hash include IO stream, and then let's do hash include list using namespace std, and then you have int main, and then you have this is the syntax. So similar to vectors, string. If it was vector, here you would have to say vector string and then the name. Name is, let's say, yesterday we took cars example for, like, let's say a different example. Let's say books, and then similar to how you would do for vectors, right? I'm going to say what is a book that we know. Let's say deep work, and then another book would be, let us say, what is another book that we know? All right. What's a good book? I'm trying to think of a good book. Hmm. All right, we'll keep it as meditations, and then let's have uh, let's have rich dad poor dad, rich dad poor dad, and what is another book? Another book. Let us say psychology of money. So that is four books, good enough. Now, for example, what can we do using these? We can retrieve these elements using enhanced for loop. So I'm just going to say for book, book in books. That's what it means for book in books. I'm going to say we have to see out, right? Books, see out books, and what have we done? Okay, let me just say string here, string, and then see out book, and then either handle or hash n, whatever it is. Let's put hash n and then terminate. So let's see what happens now when we compile it. So let's see. Just going to switch this into list and then here as well. List compile. Right, it's compiling and now this and delete. Okay, so it printed this way. All right. This, I think I just made a small mistake over here. All right, fine. Now let's do it again. All right, so now we got it, right? We got the elements printed, which is what we wanted. Now what else can we do? Uh, Access a list, similar to how we did it for vectors. You can use dot front and dot back. We already know that. Don't have to do that again. Dot front, dot back, push front, push back again, similar to vectors, pop front, pop back. So if you like go back to the vector live stream, yesterday's live stream. So just refer that if you're not familiar with these functions. Um, Size again, you can do that. Dot size, empty to check if it is empty. And then again looping through the list. So it is all similar to vector, but the only constraint is that you can't access element by an index. So you would have noticed that, you know, you cannot access, right, elements by the index over here, right? So that is the only constraint with the list. So others, everything is similar to vector. Let's move on. Let's see C++ stacks. Let's see, this is fairly new concept. So a stack, so let me just, I'm just going to copy this and then let me just create a new file stacks.cpp or stack.cpp, and then I'm just going to, you have to just change this to stack, right? Um, Let me just see, stack, right? So this is how you can create a stack. Um, you cannot add elements to the stack at time of declaration like you can with vectors. So you cannot do it this way, right? You cannot add elements over here. So I'm just going to remove it. I'm just going to remove this part. All right. Just remove this part. And now if you want to, let us say, let me also include the header file stack. All right. So now we are good. I think it is stack, right? Header file is stack. And now, yeah, we are good. So let me just, now if you want to add elements to a stack, you can also, there is something to note here. The type of stack cannot be changed after it is being declared. So that is to be kept in mind. And this is how you can add elements to a stack using the dot push. So let me just do that. Books dot push. Books dot push. Let me change it from books now. Let's see. Maybe something else. Let's say maybe mobile brands. mobile brands. So now I'm just going to say mobile brands dot push and Apple and the same thing, right? How much ever we want, we can just add. So Samsung and you just keep adding like that, right? And maybe Xiaomi, and last one probably, let's say nothing. And if you have to access these elements in the stack, how can we do that? Um, access stack elements. All right. Dot top function. All right. Let's do that. See out, and then you give the mobile brands dot top function, which is going to return the whatever you added at the last, which is nothing. Let us just check that. I'm going to change the name here, stack, and also over here, stack. All right, compile, and also change here. So it returns nothing. So obviously we added that at the end, so that would be at the top. So that's how stack works. And the next is pop. You can use pop similar to how you used it in vectors. This will remove the last element that was added. So if I, for example, say here, cout, cout mobile brands dot pop and save this. Alright, what's the error over here? Can you recognize? Okay, let me not see out here. Alright, okay, now we are good. So now this should return Xiaomi, right? So let's see if it returns Xiaomi because we pop the nothing out, right? Alright, so now let's see. So now it returns Xiaomi, right? Now it returns Xiaomi. So yeah, now we got Xiaomi, which is the element after popping that is the topmost element after popping the nothing, right? So yeah. What else can we do using a stack? Get the size of a stack. So again, this also works. Size empty. Can check if it is empty. Yeah. Also, let's also go through queues. So that's how we can. Uh, that's all about stack. Um, let's also go through queues. Which is also similar to a stack, but there is some difference. A queue stores multiple elements in specific order called FIFO, first in, first out, right? Um, so you have this order. To add elements in the queue, can use the dot push function after declaring the queue. So similar to how you would push in a stack, we can also do that for a queue. Uh, let me just create a new file. Queue queue.cpp, and now the header changes. QUE, okay. And then here again declaration QUE, right? QUE, and then that's how it goes. Um, so yeah, same like stack, you cannot do that. Um, Adding elements using at the declaration, right? Um, so that is not possible. So let's see. Um, Q mobile brands. Let us keep it as mobile brand itself. So this is how you can add elements. And if you want to access again, you can use a dot front, a dot back, all these works. Volvo would be the first element. Like if you look at the apple, nothing would be the last element. Whatever we add first is going to be the first element. Let's see. See out, for example, if you do mobile brands dot front and see out also mobile brands dot back, what will you get here? If you notice, right? Um, if you're going to do this, let me also. All right, now if I'm going to run this, I'm going to get the first element as apple and the last element as nothing. So let's see. Okay, let me just right q. So apple and nothing here. I didn't do and also, or you can do just hash n slash n. Sorry. So that should work. So yeah, you got this apple and nothing, which is our first and last elements. What else can we do? Front, um, front and back you have, and then you have what else? Pop also works. Pop, what happens? Removes the front element here. If you do pop over here, what happens? For example, let me just comment this out. If I do a pop over here, mobile runs dot pop, and then if I say what is the front element, see out, not front. Now what is going to be at the front is going to be Samsung, right? So let's see. So we got Samsung. So in a queue, when we pop, it's going to pop the first element. In a stack, it's going to remove the last element that we added, right? Um, Size of a queue same. However, we did other data structures. Again, empties as well, the same thing. Yeah, that's about stacks and queues. We also learned about list. So that was it. I think if I keep going, it's going to be too much. DQ, I think we can look at that tomorrow. So yeah, we did list stacks and queues today. If you have any questions, let me see that. Otherwise, we'll end the session for today. Um, all right, so I think we can end it for today. Um, yeah, so let's uh, let's end it and let's see. I think we'll be able to do more coding sessions after we complete data structures, hopefully. Um, yeah, and we can look at classes simultaneously. So I think we'll do one coding session and one maybe classes and errors. And yeah, there is also another resource that you can refer to, cpp dot reference. I think it is cppreference.com. Yeah. So you can go through this. There is pretty much everything over here. And for example, if I go to say right now we are learning stack, right? So I can just even search here stack, all right. And it's going to return everything that's there under stack, right? And you can go through everything over here. Um, so it's quite helpful wherever it is used. Um, and you can go here, right? You can read through this, all this, right? And it's pretty much very detailed, and this is going to give you a very good idea of everything you need to know. And also you can just search everything, right? From here as well you can go to specific thing. For example, if you want to learn if statement or for statement, if I go here, for loop, and it's going to be there. Everything is very structured, so we can refer this. Little bit more detailed it is, but if you can read this patiently and go through it, it's going to be very helpful. All right, so with that, I'll end this live stream. And I'll see you in the next one. Until then.